History remembers the headlines. We find the bylines. This is the unsung. We exist in a state of constant connection, a world woven together by invisible threads of data. Our commerce, our culture, our very social fabric unfolds across a global network we simply call the internet. It feels as natural as air, instantaneous, infinite, and inevitable. But this seamless reality, this digital nervous system of our planet, was never a given. To understand its true origin, we must rewind the clock to the 1970s. The digital world then was a fractured archipelago of isolated mainframes. Computer networks, like the famous ARPANET funded by the US military, were marvels of their time, but they were also profoundly rigid. They operated on a principle called circuit switching, the same logic that governed the old telephone system. To send a message, a dedicated, unbroken path had to be established from sender to receiver and maintained for the entire duration of the communication. This made them centralized and terrifyingly fragile. If a single computer or a single connection on that path failed, the entire circuit was broken. The message was lost. The dream of a truly global, resilient network, one that could survive errors, or even a military attack, seemed like pure science fiction. The puzzle was daunting. How do you build a network that can withstand its own failures? A network that doesn't need a central brain? The answer, it turned out, wasn't incubating in the well-funded labs of Silicon Valley. It was being quietly formulated in a small office in France by a visionary engineer named Louis Pouzin. Pouzin was the head of a project with a modest budget and a grand ambition named CYCLADES. He understood that the circuit switching model was a dead end. For a network to be truly robust, it needed to be decentralized. His solution was a stroke of genius, revolutionary in its elegant simplicity. He called it the datagram. Instead of a single, continuous stream of information, the datagram model broke every message, no matter how large, into small, independent packets. Each packet was like a digital postcard, individually stamped with its final destination address and a sequence number. Released into the network, these datagrams behaved not like a train on a fixed track, but like a fleet of delivery drivers. They could travel independently, find their own routes through the maze of connections, navigating traffic and bypassing broken links in real time. If one path was blocked, a datagram could simply be rerouted. If a packet arrived out of order, the sequence number allowed the receiving computer to reassemble the message correctly. This was the end-to-end principle. All the intelligence, all the error checking and reassembly was placed at the edges of the network on the sending and receiving computers. The network itself could be simple, dumb even, a mere delivery service. It was a radical departure from the top-down, control-obsessed designs of the era, and it worked beautifully. CYCLADES became the first network to prove that a reliable system could be built from unreliable parts. Meanwhile, across the Atlantic, two of America's brightest engineers, Vint Cerf and Kahn, were wrestling with a monumental challenge. Their task was to create an internetwork, a way to connect the ARPANET with other, different types of networks. But the existing protocols were clunky, proprietary, and fundamentally incompatible. They were stuck in the old circuit switching paradigm. Then, at a conference in 1973, they encountered Pouzin's work. They saw his presentation on CYCLADES and the datagram. It was the missing piece of the puzzle. They adopted his blueprint, the concept of simple, independent packets and smart endpoints, and used it to design the protocol that would become the universal language of the modern Internet, TCP/IP. The foundation of our digital world was laid, built directly upon a French design. But as the Internet exploded from a government project into a global phenomenon, the story was rewritten. It became a quintessentially American triumph, a testament to the ingenuity of Cerf and Kahn, who would rightly be celebrated as fathers of the Internet. Louis Pouzin, however, was relegated to a footnote. The reasons are a complex mix of politics, economics, and culture. He was an outsider, a Frenchman in a field dominated by the American military-industrial complex. His government-funded project, CYCLADES, was eventually shut down, its budget reallocated to the national telecom monopoly, which favored older, more profitable technologies. And perhaps most critically, Pouzin was an academic, not a businessman. He shared his ideas openly, publishing his findings for the world to see, believing that innovation should serve the public good. The final lasting credit went to those who wrote the final official specifications and commercialized the technology. It wasn't until decades later, long after the Internet had reshaped society, that the world began to correct the record. The quiet engineer from France began receiving prestigious awards, a belated acknowledgement of his foundational role. Today, when we champion a free and open internet, we are defending the legacy of the datagram. The internet's decentralized, resilient, and beautifully chaotic nature is a direct descendant of Louis Pouzin's core idea. His story is a powerful reminder that true innovation is rarely a solo act or a single eureka moment. It is a quiet, collaborative, and international conversation. The most important ideas don't always come from the loudest voices or the biggest budgets, but from the unsung minds who dare to see the world not as it is, but as it could be. For more hidden histories that shaped our world, subscribe to The Unsung.